So we've started talking about legacy code and refactoring, and one of the big messages, in my opinion, was that legacy code often is code without tests, because not only does that mean that you cannot safely modify it without knowing if you've broken something, but it also means that you are lacking some documentation about how the code is supposed to work, the kind of information that if you're approaching an unfamiliar code base, you would want to know. So the way that we get around this is with characterization tests, and that's our next topic. So what's the point of characterization tests? Basically what we said, you don't want to write code without having tests because you don't know if it's safe, but maybe you don't have tests because the code base doesn't have very good test coverage. You can't create those tests without some understanding of the code, so how do you get started? How do you solve the chicken and egg problem? And the answer is you sort of cheat. The goal of a characterization test is to establish something about the way the app works today, and you could use this as the basis for improving your test coverage. So essentially, if you remember our acronym for FIRST, the R in FIRST is for repeatable, and whatever the app is doing today, we want to make sure that we can capture that in a test that's repeatable so that we can improve coverage around the parts of the app where we might need to be making changes. The biggest thing to keep in mind here is that when you're doing characterization test creation, don't try to improve the app. Your sole goal at this point is to improve the level of test coverage around the aspects of the app that you may have to modify. So what's a characterization test? The simplest kind to explain is an integration level, or if you want, an acceptance level characterization test. And it's basically the Cucumber scenarios you don't have. Now, of course, if you're not using Rails or you're not using Cucumber, substitute your favorite tool for creating integration level tests. But the idea is that if you watch people using the app and essentially try to reproduce their workflows in an integration test, we've already seen that pretty much if a human user is able to do it, then it is scriptable using some sort of a test framework. And because basically by doing that, you're following the principles of BDD, you don't have to understand how the app works internally to reproduce these behaviors. You just have to be able to consistently reproduce in an automatic way what the user is doing. And because you're just getting started, you don't really understand the app's domain vocabulary yet, it's fine if these are sort of stylistically not great Cucumber tests. You can do a verbose, detailed imperative scenario now. Maybe you improve them later, maybe you don't. But again, the goal is let's capture what the app is already doing in a way that is repeatable and reproducible so that as we make changes, we know we're not messing anything up. Now, of course, we've already said that characterization or integration acceptance level tests by themselves are not enough to give you robust test coverage. So what about doing the more detailed or lower level tests, like unit level or module level? How do you write characterization tests at that level? Because there, it does require some understanding of the details of how the apps work, maybe at the level of a class or even individual methods. Basically, you write tests to learn as you go. So here's an example. We're working on an app, and part of the app is a sales flow, and it should calculate the sales tax. There's no tests that are trying to call that code path, and yet we need some because we're going to make some changes that might touch parts of that code path. So what might we do? Well, we could start out by using the technique of creating a double for something and saying, when I compute the tax on it, it's going to equal some number. I'm just making up a number out of the air, which is almost certainly wrong, but the goal here is to essentially use the test to poke at the app and see what actually happens. And very likely what will actually happen is, because I created this double, but I didn't actually give the double any behaviors, more than likely the first time I run the test, the error I'm going to get is that the order double is being asked to do something that only a real order would know how to do. So a message that I might get might be something like, in trying to call this code path compute tax, the order double tried to call a method called getTotal. But it can't do that because it's only a double and it doesn't have any behaviors. So, okay, fine, let's give it a behavior. This time, we're going to give it a double. We're going to make the double also have a stub for a method called getTotal. Again, notice that we don't actually know what getTotal is supposed to do. All we know at this point is that when we call compute tax, someplace getTotal is supposed to be called. So fine, we'll arrange for it to return another canned value, which again, I'm just sort of making up out of thin air. And now we try to run the test again. But of course, because I made up those return values, it's almost certain that those return values are completely wrong. But this time, I get a better error message in some sense, which is the code path ran, but the compute tax method was supposed to return 99.99, negative 99.99. Instead, it returned 8.45. Okay, good. If I take on faith that what the app does now is something worth capturing, all I have to do is change my expectation, and look, I have now essentially created a little bit of test coverage for that code path. so that if in the future I do something that messes up the correctness of that code path, I now have at least some probe in place. So basically, you're essentially poking at the app to see what it does, and when it does something, you capture that thing so that now you can push the button and cause that same stimulus to be repeated in the future as you make changes to the code. It seems almost too easy.